Again, most of your questions are probably on the antiderivative part of it, right? Getting the antiderivative right. And then also the solving for y part. And so let's talk about all the situations that can happen, because we want to deal with like a sine situation or an arc sine or, any of those. We talked about several that were natural log yesterday. But let's look at 20. What was that one? Dy over dx
equals x over 1 plus y squared.
X over 1 plus y squared. Okay? So again, it's a mixture of x's and y's. It's not one we could solve, by straight antiderivative, but it is separable. Separable means that we can get the y's on one side, the x's on the other. It always starts by moving the dx over to this side. But as you kind of get better with the algebra of it, you just realize, okay, I can move that dx over there, and I can multiply this 1 plus y squared over here. So it ends up being really in one step. It ends up being that. Now you could put parentheses around that, but I think we understand well enough that that's what it means, right? That's kind of a separate thing unto itself. We do the integral of both sides, which means the antiderivative. So what's the antiderivative of this? What's the antiderivative of what? Y, right? Because it's with respect to y. That's right. So it's not x, but it's y. Plus y cubed over 3 or 1/3 y cubed. We could put a plus c, but we'll save it for the right side. Antiderivative of this, x squared plus c. Now, something I may not have made real clear yesterday is, was there an initial condition on this one? What was it? Y of 2 equals 3, okay? So you can, anytime after you do the antiderivative here, you can plug in your initial condition at any time after. So you don't have to wait till you solve for y to do that. Sometimes that can actually be better, especially when you get into like plus minus, like if you do the square root of both sides and then you got a plus minus and you're not sure about that kind of thing. So sometimes it can almost be better to plug it in, now. Now in this one you pretty much have to plug it in now, because we just really can't get the y by itself. So sometimes, even though we said solving a differential equation means finding the original function y, it's possible the original function is not a function. It's a relation. It's just a relation between x and y. Okay? There is no way to move y's around here to get y by itself, so it's okay to just stop. Now, we do need to plug our initial condition in, so we put a 3 in here. 3 cubed is 27 times a third would be 9, plus 3, so that'd be 12. Put a 2 in here, 4 times a half is 2, so c would equal 10, is that right? And then put that back into here, so take out the c and replace it with a 10. Okay, and so that would be your solution right there.
So the solution doesn't have to be like y.
It doesn't have to be y equals. Now, I would say, if you can, I want you to get it into y equals. Okay. For the quiz, probably going to be ones where you can get the y by itself. Okay. But it can happen where you don't get the y by itself. Okay. Was there one in there that had like an arctangent or a sine or cosine? 27. 27. Okay, so dy over dx equals, what was that? Just plain old 1 plus y squared. Just like that. Okay, this was that example, and this was similar to the example I gave where it's all by itself. It looks like maybe it's not a separable because it's got this plus sign in it, but it turns out that it is, because we treat that as one thing. So we move the dx, we multiply the dx over here, and we divide that whole quantity. So it ends up being 1 over 1 plus y squared dy over here, and then just plain old dx ends up being over here, which of course there is a 1 there. Okay, so when we do the antiderivative here, we get arctan of y, right? And that's just one of those we have to have memorized. Okay, and then over here, the antiderivative of 1 is x plus c. Now, we can get, how do you get the y by itself? How do you undo an arctangent? You do tangent. right? Tangent and arctangent are inverses of one another. So if this was tangent y equals x plus c, then you would do the arctangent of both sides. You'd have arctangent x plus c. Okay? Now, I don't think there was an initial condition on this one, was there? So you didn't have to worry about that. But so we would do the tangent of both sides. So this would be tangent x plus c. Okay? And that would be your final answer. Now, if they would have given you an initial condition, it probably would have looked something like this. They probably would have said, let me just give you one. Let's say y of 0 equals let's say it was that. Okay. Well, so you might have to do some trig to this. Okay. You do have a calculator on the quiz next week, though, so you could do that on your calculator. But if we put a 0 in here for x, we get tangent of c equals 1. Well, when does tangent equal 1? Isn't that pi fourths? 2 over 2, root 2 over 2, opposite over adjacent would be 1, it would be pi fourths. Now it would also be down here in this quadrant too, I mean, so it could be other, but I would say we would go with pi fourths, probably be some sort of limitation on it, but so pi fourths would be your c, so it'd end up being something like that. Okay, but if they didn't give it to you, you just stop there, you have tangent of x plus c. All right, any others there? Yeah.
I have a question. For 22, I ended up like 3 equals square root of.
What was the original problem?
Oh, it was x over y.
Just x over y. Yeah. Okay, so we have y dy. Let me just catch up to you here. So just like this.
Yeah.
Oops, that's dx. So 1/2 y squared equals 1/2 x squared plus c. Now, so what I would do if I multiply everything by 2, I'd have y squared equals x squared. I think I would do that. I'd multiply everything by 2, but what would you do with that c? You could, but what's 2c? To me, that's just c.
That was my question, but then like in the end, I ended up like 3, when I plugged in the initial condition.
Did you do 2c or c?
I did 2c.
All right, let me show you the difference. So over here, let's say we had done, let's say we had done 2c, okay? That's fine. So now what's the initial, and then we could do, now this is where I was saying it's not a bad idea to put in the initial condition. What initial condition did they give you?
I think it was y of 2 equals 3.
Y of 2 equals 3. Now, let's talk about this a minute, because if I do the square root of both sides, I really need to do this. I really need to do a plus minus. Now what that means is there's a top half and a bottom half. Okay, the initial condition with differential equations, you might remember we did some slope fields where there were different branches. If the initial condition was up here, the slope field kind of went like this. If it was down here, it kind of went like this, right? We had different branches of it. What depended on our initial condition? Well, what we have here is both a positive and a negative branch for the y. Well, what initial condition did they give me? Positive or negative? Positive. That tells me I want the positive of those, right? I don't want to put a plus or minus on there now since they gave me that. Okay, so go ahead. So you said you had 3 equals
Start of 4 plus 2c.
4 plus 2c. Okay, so we square both sides. We get 5 equals 2c. We get c equals 5 halves, right?
Yeah, but like in the answer, they had c equals 5.
Well, right. Well, I don't know if they had c equals 5. Tell me what they had for the answer. They had y equals
Square root of x squared plus 5.
Right. That's the answer. But now think about this. You got c as 5 halves. But you've got to go back up here and plug it right there. So you put the 5 halves in times 2, then it becomes 5, right? You see what I'm saying? So she's exactly right. She's got a different c than I would get over here, but however, when you plug it back in, it'll come out the same, right? So if I finish this one in the blue over here, if I do the square root, so if I do the square root here, and I won't put the minus one because I know, so now I've got x squared plus c. Now if I put my initial condition in, I get 3 equals square root of 4 plus c. Square both sides, I get 9 equals 4 plus C, so I get C equals 5, and then I put that back right there. Same thing. Same thing. So you should get the same thing either way at the very end. Yes, your C, if you do this where I do 2C and just call it C, then my C will end up being different than the C there, but when I plug it back in, it'll all work out, and everything will be the same.
But like, so when you have like multiply 2 with C, should you, like, is it easy to just write C then?
I think so. I think anytime you're subtracting C or you add another C, just call it C. I think that's easy. Okay? All right, so that's your final answer for that. Okay, good question. Anything else? Okay, let's pull out, before we start on the sample packet, let's pull out the 2012 and the 2015 free response packets. There's a couple problems we haven't done in there, I think, and there's one that I want to talk about on each one of those that involves differential equations. Invariably, not every year, but invariably there is a free response question that is on differential equations. And every year that tends to be, when I get our AP test results back, it tends to be one of our lower scoring sections. Now, to be fair, it's nationally, it's usually one of the lowest scoring sections, okay? So, we want to kind of review and look at these problems, and we'll have a chance to do some more here before our finals next week. But as far as our quiz next week, this is the type of stuff you're going to do. There'll be one or two of these, just like these problems here. Okay, here's a differential equation. It's separable. Solve it, separate the variables, solve it. Maybe there's an initial condition to plug in, and that's what you do. So they look just like this. Okay? All right. So let's do the 2012 first, and let's go to problem number 5. Let's go to problem number 5. Okay, with the baby bird. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, so in other words, the bigger that gap, the faster it grows. Does that make sense? So in the early stages, it's going to grow faster when it's younger. Okay? And then as it gets closer to its adult weight, the growth slows down. Okay? So it's proportional to the difference between its adult weight, which would be the 100, and its current weight. B is its current weight. At time 0, when the bird is first weighed, it weighs 20 grams. So that is this initial condition right here. Right? If B is the weight of the bird in grams at t times after its first weigh, then this would be the differential equation. That's the rate. Okay? It's the rate, it said, the rate is proportional to, and that's the 1/5, that'd be like the K, proportional to the difference between its adult weight and its current weight. So that we did some problems like this where I gave you a sentence like that. You had to write the differential equation, right? When we were doing this way back when. But they've given it to you there. All right, so let's go through some of the questions. So it says let y equals b, or big B, is a solution to the differential equation, right? Now, that is separable. We could solve this. Do they ask us to solve it? Yeah. Look at C. It says use separation of variable, right? So we're going to get to that. But let's go through these first ones here first. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reason. What would you do? Makes sense just from the sentence they said, right, earlier on. But what would you do to get some numbers to show that? Wouldn't you just plug it into this equation? Very easy, right? Because B prime, that difference equation, is the rate that it's growing. So you put a 40 in here, you're going to get 1/5 times 60, which is 12. So at 40, this would be 12 grams per, day? And at 70, you get 100 minus 70 is 30. times a fifth would be 6 grams per day. And that would explain your reasoning right there. When it weighs 40 grams, it's growing at 12 grams per day. When it weighs 7 grams, it's growing 6. So pretty easy, right? And that's not unusual, you know, that there's parts of the free response that seem easier than others. Okay? All right, next one. What does this mean? That's the second derivative. So that would be the derivative of this. Now, if you like this other notation better, then write it as b prime if you prefer. And we certainly could distribute this 1/5 through here, right? 20 minus 1/5 b, if you like that better, I think that's fine. Okay, now, notice it says find the second derivative in terms of b. What's that mean? What's it mean in terms of b? Not with respect to, no. Okay, that's pretty close. Write y in terms of x. Would mean to get y equals, and on the other side would be x's, right? In terms of x means your problem's going to have x's in it. In terms of b means you're going to have b's in it. That's what it means, in terms of b. That's good, because if they just said in terms of t, that would have been bad, because we don't know what the b equation is, right? We haven't solved it yet. That's that last part. So, what is the second derivative? Okay, we do the derivative of this. What's the derivative of 20? Nothing. What's the derivative of negative 1/5 b? Negative 1/5 b prime, right? This is implicit differentiation. Now, in terms of b means it's going to have b's in it, but it's still with respect to what? We're doing the derivative with respect to t, right? We're still doing it with respect to t. So b, so this is like implicit differentiation. Okay, so we have to tack on a b prime. You do the normal derivative, so 1/5 b, the derivative would be 1/5, but then you got to tack on a b prime. Okay, that's that implicit differentiation. All right, now, use that to explain why the graph of b cannot resemble this graph. Now, one reason we could say it's not that graph, the weight's not the graph, because we said, when's it growing the fastest? At the beginning, and then it levels off, right? Well, is this one doing that? I mean, so just from a common sense standpoint, it looks like the weight's pretty flat for a while, then it goes up fast, and then it levels off, and it doesn't look like that's what this one's doing. But that's not good enough. They want us to use this second derivative to explain why this can't be that graph. Now, what is second derivative? Think of the chart. What does second derivative typically tell us? Concavity. Well, look at this one. This is kind of concave up, looks like, and then switches to concave down. Okay? Well, let's look at this right here. Here's our b double prime right here. Now, what do we know about b prime? Isn't b prime positive all the time? Why? Because the bird is always gaining weight, right? B is its weight. So b prime is the rate of change. So if b is always increasing, right? If the b graph, which this graph's always increasing. But if b is always increasing, b prime always has to be positive. So if b prime is always positive, what is this thing I've just circled here? Well, no, always negative, right? The thing I've circled right here is always negative. Since b prime is always positive, negative 1/5 b prime is always negative. So if the second derivative is always negative, that means b is always, no, what you said, concave down. If b double prime is always negative, then b is always concave down. So the b graph has to always be concave down, and this graph does not show that. Okay? And again, kind of like we were saying, we know that graph should look like that. It's gaining weight fastest at the beginning, and then it's gradually leveling off. Okay? But that would be how you would reason that. Okay? Again, using the chart and things we've talked about. Okay? All right. You've got to be able to think through those things. Again, but understand, how many different things do we have? The 6 free response questions are about the big ideas we've learned. And there's no idea bigger than the chart, right? Increasing, decreasing, concave up, concave down, those relationships between B prime, B double prime. You should be looking for all kinds of ways to use those on the free response questions, right? I mean, yeah, we've been in this class for a long time, and we've done a lot of stuff. But really, you can boil it down to some just a few pretty big ideas. Now, if you got an area problem, there's going to be only a few ways you do area problems. The volume problems, right? We've been talking about those a lot lately. There's certainly those max, min, number lines, but a whole bunch of these are going to be about the chart. So be looking when you get into second derivative and first derivative and stuff like that. You got to be thinking of the chart, increasing, decreasing, because that's what it's going to be about. They're going to look for all kinds of ways to quiz you on your knowledge of that. Okay, finally, use separation variables. Now, it doesn't always use those words. Sometimes they would just say, find this particular solution. Okay, so let's do it. So we got dB dt equals 1/5 b, what was it, 100 minus b? Okay, so what are we going to do? We're going to move the dt over, obviously. What's going to stay on the right side? The 1/5. What's going to go over to this side? 1 over 100 minus b, and then dB, right? I mean, this looks very much like the second one we did in class yesterday, right? Now, on the left side, what is that antiderivative? Isn't that an ln? Right? Now, I cautioned you yesterday, you don't want to make everything you see an ln. This one is. It's b to the first power. We're doing it with respect to b. So this is an ln of 100 minus b. Now, there is something missing there. Now, yeah, but you don't really need it.
Plus C.
No, you're right. We could put a plus c, but we're going to put that over on the other side. This negative on that b. Remember? Because if we were going to do the derivative, think about it now. If we were going to do the derivative, now the one we did yesterday was w minus 300, so we don't worry about it. If we were going to do the derivative of this, what would it be? It'd be 1 over 100 minus b times the derivative of the inside, which is -1, right? There's a negative on that. And so now remember, it's usually reciprocal, but -1's its own reciprocal. If we had sine 2x, we were going to do the antiderivative, we had to kick out a 1/2. Right? So don't forget about that. So that negative sometimes is a problem. People forget about it. And then this would be 1/5 t plus c. And notice they said find y equals b of t. So back to your question, do you always can you solve for y? Well, if it says find y equals, then they are expecting you to do that. Okay, so what do we want to do? So in other words, we're finding, that's not y though, it's b. So we're trying to find b. B equals. So let's multiply that negative over there. So we get ln 100 minus b equals, negative 1/5 t, and I would still keep that at plus c. Okay, now we got our e thing that we do, 100 minus b equals e raised to the negative 1/5 t plus c. Remember how we split that apart last time? I think that's still a good idea right here. So I would write that 100 minus b equals a e to the negative 1/5 t. Okay, we did that with where we split that apart with that plus c in there last time. And then let's see, I think it'd be best to add the b over to the right instead of dividing by negatives, and subtract that over, so it'd be 100 minus a e to the negative 1/5 t. Right? Now I haven't put my initial condition in yet. So now we'll do that. So we'll put a 0 in for t. E to the 0 is 1. So I get 100 minus a equals 20. Add the a over to the right. Subtract the 20. I get 80. So final answer, 100 minus 80 e to the negative 1/5 t. So there you go. 2012. this was one of the free response questions. There typically is a differential equation one in there. And often it involves doing a separation of variables to solve it. Not every year, but a lot of years there is where you solve.
Why is the negative, or why is it 1/5 negative?
Right here we have this negative in front of this. Divided that over. Yep, divided that over. Okay? All right, let's grab the 2015 packet. And let's look at number 4. I don't think we've done that one yet, have we? We did part A, the slope field. Yeah. Now, let's review that real quick because that was a long time ago. So slope field is just plotting of points. So these are the slopes, y prime. So if I put in 0, 1, I put a 0 in for x and a 1 in for y. 0 minus 1 is -1. So that means right here, there's going to be a slope of -1. And if I put in 1, 1, I'd get 2 minus 1. That's a slope of 1. So I'd have a slope of 1 right there. Right? 0, 2, put a 0 in for x, 2 there, -2. So it would go like that, so forth. So wherever there's a dot, you would plug those in and get those slopes and then sketch them as a slope. Okay? All right. Now, part B. Find what? What is this? Second derivative in terms of x and y. So you got y prime equals 2x minus y. But remember, we're doing it with respect to x. Okay? So what is y double prime? What's the derivative of 2x? 2. No. Because we're doing it with respect to x. Right? So x prime would be dx over dx, which is just 1. So we can just put 2 there. What's the derivative of y? Y prime. Right? Normal derivative of y would be 1, and then put that on y prime. 2 minus y prime. Now it says determine the concavity of all solution curves for the given differential equation in quadrant 2. Give a reason for your answer. Now, I think I would do a couple of things here. First of all, in quadrant 2, you know the x's are negative and the y's are positive, right? X's are negative and y's are positive in quadrant 2. Okay? Now, I think it might not hurt to take this and substitute it right in there. Right? Because that's y prime. So I didn't do that back on the bird problem because we didn't need to. Okay? But y double prime then is going to be 2 minus this quantity, 2x minus y, which would be 2 minus 2x minus y. Now, actually, I needed to do that anyway, because it says right here to find the second derivative in terms of x and y. So I really couldn't leave it like this, because that's in terms of y prime, right? Go back to what we said earlier.
Plus y.
Yes, thank you. Thank you. Right? Because it said in terms of x and y, that means they want x and y to be in the problem, in the answer, not y prime. They don't want y prime in the problem. So that's actually the answer I would have needed to give right there. Okay, now, in quadrant 2, and maybe I probably glossed over that, but that's really the secret to this problem right there, is looking at that. Because they're saying determine the concavity. Well, we need to know if y double prime is positive or negative. Well, how can you tell? Right? Depends what x and y are. But when they tell you it's quadrant 2, you know the x's are negative and you know the y's are positive. So if the x's are negative, what's it do to that? Makes that positive. So all of a sudden 2 is positive, this term will be positive, and the y will be positive. So y double prime is going to be positive all the time in quadrant 2. So the concavity, concave up. And again, you would probably have to explain that. Somehow you'd say, well, you know, in quadrant 2, the x's are negative, the y's are positive. So therefore, 2 minus 2x plus y will always be positive. So y will always be concave up. The graph will always be concave up. But see, again, there you go. It's just chart stuff, right? It's concavity is determined by that. Okay, let f y equals f be the particular solution with this initial condition. Now, this is not, though, separable, right? This one's y prime equals, what was it? 2x minus y. Was that our problem? That is not separable. I mean, we couldn't, if we moved the dx over here, if you move the dx over here in this quantity, there's just no way to get that x and that y separated on one side.
Do we divide by y? Just do 1 there.
If you divide by y, then you got a y under here too, though. You see what I mean?
Yeah.
Yeah, there just is no, we could try some things, but no matter what we did, the x and y would stay together. They will not separate. Okay? So, but that's okay, because they didn't ask us for the solution. They just said y, the original y is the solution. Does f have a relative, that means local min or local max? Well, all we need there is a number line, right? We just need a y prime number line. So we need to know where y prime is 0, right? So where is this 0? Well, add a y over to the other side when y is equal to 2x, right? Now notice they said at x equals 2, right? At x equals 2. So when x is equal to 2, we get, oh wait, time out. So we get, let's plug it into here. Okay, so we get y prime equals 0. That would be 4 minus y equals 0. That would be when y is, oh yeah, no, same thing. I would have got the same thing there. 4. Okay? So now, time out. Oh, initial condition. I didn't use my initial condition here. Well, I have to use it right now. What did we just get? When x equals 2, what did we get for y here? 4. Well, what is y supposed to be when x equals 2? 3. So what do those two pieces of information right there tell us? It means, okay, let me back up. I didn't do a very good job of setting that up. Okay. If there's going to be a local min or a local max, y prime has to be 0, right? So I set this equal to 0. Well, the only way y prime can equal 0 and x be a 2 is if the y is 4. Well, when x is 2, can the y be 4? No. Not and have y prime be 0. So what that tells us, well, I guess to be honest, let's approach it from this standpoint. If f of 2 is equal to 3, that means x is 2 when y is 3. Let's do it this way. Instead of setting that was probably confusing. Instead of setting y prime equal to 0, forget that. Let's just plug the point 2, 3 into y prime. Let's just do that. Okay? So we get y prime equals what? 1. Okay? So at the point 2, 3, the slope is 1. Right? That's what we just found. At the point 2, 3, y prime, the slope is 1. So is there a local min or local max there? Can't be. Right? Because the slope's not 0. That's what I was showing the other way I did it, but maybe this is probably just easier. Take the point they gave us, 2, 3, because they said at x equals 2. Well, we know 2, 3 is the point there. Plug that into y prime, and we get a slope of 1. So there can't be a local min or local max. Okay, so it's neither, and that's our justification, because the slope is 1. Okay? Find the values of m and b for which y equals mx plus b is a solution to that differential equation. Okay? So again, what did we just say? We said solution to this differential equation, we're going to plug in, for y, I'm going to plug in mx, let's see, what would be a good way to do this? Let's think about this a minute now. Are we still using this point here? Find the values of the constants m and b for which y equals mx plus b is a solution to that differential equation. See, I would assume that we would still use this point, but I'm not sure that's true. Because if we plug, whoops, because we're basically going to need to get two equations that we can work with here. We would have that, right? We substitute that y in for there. And also, if this is a solution, then y prime of this would equal m. So I'm not sure that helps us. Find those two equations. Let me think about that one a little more. Does anybody else see something I'm missing? Well, that's what I see. That's the part I'm coming back to. We knew the slope was 1. So does that mean, but since we found the slope was 1 at that point, that would tell us m, right? And if we knew that, then we could put a 2 in here. If we knew that this was 1, then we could put a 2 in here for x, right? If we were, that's the part I'm unsure of. It doesn't, for which this is a solution. So this is talking about a particular solution. I'm afraid this is a different solution, but you're right. If we use the slope we found back here, because a lot of times you do, you take a result from before, then this would be pretty easy. We'd have 4 minus 2 minus b equals 1. So we'd have 6 minus b equals 1. So 6, so what? B would equal 5. So we'd have m equals 1 and b equals 5 if we use this point from back here. Yeah, let's use it. There's a kind of sneaky. Oh, God. Thinking ahead. 4 minus 2 is not 6. Sorry. 4 minus 2 is 2. So 2 minus, so what do we get for b? So b would be 1. But that's using that point back there, right? Back in part C. I'm not sure we can. I'll look that up and see for sure. Okay? But that would make sense. That would make sense if we would use that, because I'm not sure we have enough information otherwise. All right. So the rest of the time, and then tomorrow, knock on wood, well, probably either way, it doesn't really matter if we have class or if we have a track meet or not. We'll probably be spending a lot of time, all our time working on that sample 4 package. So I got a couple of the answer books up here if you want to look at those. So we want to use the rest of the time to get a good start on that, and then a lot of it done in class tomorrow. That mostly spend time working on that, okay, for pretty much the whole time, okay. And again, come ask questions. Though look in the answer book, but also ask questions so I can help you out with them. But we're only about a week away from our this first section, right? The multiple choice, 28 questions, multiple choice, no calculator. So let's go to work. Yes.
How many finals do we have? 4?
We have one final. It's 4 points. That sounds better. That sounds better. That sounds better than 4 finals. But you're right. If you want to brag to your friends, you're like, hey, shut up. I got 4 finals. Okay. So keep working.
Should we try to get to the after the no cut? Is that our goal?
For tomorrow?
Yeah.
Yeah, I think I would say a good goal for tomorrow would be to get the first 28, that first section done. I mean, that's a pretty good goal because that section's supposed to be 55 minutes, right? What do we got left? 42 minutes? So, right? If this was the actual test right now, so we have, right? I mean, you would have to get that much done, right? The one on Friday is going to be 55 minutes to do those 28 questions. Okay, next Friday. So, you got to move right along. Okay? So by tomorrow to have that section done would be a good goal. Now that said, you may not get all of those done, but you may skip a few and have to ask questions about it. Taking a break.
Research paper's finally done, so.
Oh, there you go. So you got all kinds of time. Put it this way, you take your break tonight, you'll just have more to get done over the weekend. Because, you probably want to get, it's not like you want to have it all done by Monday, though, because, we're going to be reviewing some other stuff as the week goes along next week. But we also are going to be preparing for our Wednesday quiz. So we are going to interrupt our final review, the first part of the week, to be focusing on the quiz. So, So that's why between now and Monday is more about the final, thinking about the final.